So we dropped a perpendicular from B to AC, and we called it Bx, and we want to find out the length of Bx. And there is a number of ways of doing this. For example, you can think of this side as t, then this is 10 minus t. So you can simply find t and then find Bx. So this is a right angle triangle, so you can use the fact that this is 6 square minus t square. This is Bx square using Pythagorean theorem. And you can also use the same deal here, that is 8 square minus 10 minus t whole square. So simply solving this equation, you'll get 36 minus t square equal to 64 minus 100 plus t square minus 20t. So you get 36 minus t square equal to 64 minus 100 minus t square plus 20t. So clearly negative t square will cancel, and we have 36 equal to negative 36 plus 20t, which means t equals to 72 by 20. So if this is the value of t, which is, you can simplify it, but we really want to find out Bx. So then we can find out Bx. So Bx whole square is 6 square minus 3.6 whole square. 72 by 20 is 3.6, of course. So all we need is an approximate value of Bx. So there is a number of ways of computing this. Let me just do one. So 6 minus 3.6, 6 plus 3.6, and this happens to be 9.6, and this happens to be 2.4, and you can easily compute 9.6 times 2.4. So it's so Bx is approximately square root of 23.04, which is certainly less than 5, but more than 4. So this value of Bx down here is somewhere between 4 and 5. Now, this is the part where you will need intermediate value property. If you drag Bx or the point x to the left, notice that it will continuously, so value of Bx or the length of Bx, value of Bx will continuously increase to 6, right? It will continuously increase to 6. So it will start from 4 point something, and then it will increase to 6, means somewhere in between. Since this increase is happening continuously, it will be achieving the value of 5. Bx is the shortest one from B to AC, so it will gradually increase. The length of Bx will gradually increase as x moves towards A, and somewhere in between A and x, it will achieve the value of 5. Similarly, as it moves rightward, uh, it will start and increase from 4 point something to 5 somewhere in between, then 6, then 7, and then finally to 8. So we have got how many straight lines which have integer lengths now? We have this one, 5 to the left of bx, and then we have 5 to the right of bx, 6 to the right of bx, 7 to the right of bx. The key idea is this, that since the length of bx increases continuously, it will achieve all intermediate values from 4 point something to 8. This requires a little bit of idea from calculus, but intuitively this is very clear that this must happen. So we can say for 4 of those line segments that are drawn from B to AC, 4 of these line segments have integer lengths. You can go back to problem number 16 in AMC 10A 2018, and you will see that that problem has a very similar flavor. Link in the description has more discussion. Thank you for watching.